Welcome to Pratidhwani, where we try to humanize science. I'm your host, GV Pawan Kumar. It is my delight and pleasure to introduce you to a wonderful researcher and a person whom I know for a very long time, Vijaykumar Krishnamurthy. Vijay has been a long term friend dating back to my own college days, but he has also done some outstanding research and outreach in science. His research includes various different aspects of soft condensed matter physics, including a fascinating area of physics of life. Vijay is a professor at the ICTS, which is the International Center for Theoretical Sciences at Bengaluru, and he has had a very long and illustrious career dating back to 2000s, where he did his PhD at Indian Institute of Science, and also a PhD with some on very interesting problems. But we'll look at those aspects as we go along. But what is very fascinating about Vijay, he's also the brain behind copy
Copy
with
with Kiri.
curiosity, copy with curiosity, where the copy comes from the Bengaluru copy, where that's a wonderful initiative which Vijay has been also spearheading, and it has really had a very great impact in the scientific community, not only in Bengaluru but also across various parts of India. So, with a very brief introduction, I welcome Vijay to Pratidwani.
Thank you, Pawan. Fun to have you here.
So, Vijay, we will start with the origins. Tell us a little bit about your kind of upbringing, and also how you got influenced in terms of going into science and your schooling days.
Okay, I was born in Bangalore, brought up in Bangalore, did all my schooling in Bangalore, and in fact did my PhD also in Bangalore. I just went out for a postdoc and I come back to Bangalore and stayed in Bangalore. So Bangalore is very comfortable for me. So most of my schooling was in local schools in the state syllabus.
Hmm.
The kind of topics that would fascinate me a lot were not scientific initially at the beginning. So there wasn't a clear picture of going into science as a career and so on. Sometime in the maybe in the high school days, I clearly remember, or even middle school days, a couple of books really made a big difference. So this was the late 80s or early 90s when there were lots of books from Russian publishers,
Rashif,
Mir,
yeah.
Raduga, and so on and so forth. One book I particularly remember very well is Krushansev Duradarshaka Tidsudin. It was the Kannada version. It's all about the
Nice.
telescope, basically. So that my parents got me, and they would read out things from that. And that made a huge difference as to why one should pursue science. And the fascination, as most of us, we come to science fascinated by the stars. So just look up, and so that was the first thing that made a difference. The other book that I can vividly recall is a collection of articles in Tinkle. So Tinkle
Hmm.
used to have these small articles on astronomy. They sort of put together that and made a digest. And there was a whole digest, particularly in astronomy. And that was absolutely a game changer because that sort of fascinated. And, rather than being just awestruck by the sky, one realized that you can actually study it. And at some point, one of the things that really made a difference and said that I should become a scientist is I was reading a biography of Carl Sagan.
Hmm.
And at some point, there's a discussion between Carl Sagan and his grandfather. I can't remember the exact book. So his grandfather asks him, "What do you want to be when you grow up?" Carl Sagan says, "I want to be an astronomer." His grandfather says, "Oh, that's all right, but what do you want to be when you grow up?" And Carl Sagan says, "I want to be an astronomer." No, that doesn't mean. I mean, that's something you do as a hobby. What do you do for a living? So Carl Sagan thought, okay, then maybe it's not possible. And then he says that when he discovered that you can actually be paid to do astronomy, that was a fantastic thing. So I had that aha moment too, that you can actually do science, you can get paid and make a living by pursuing what you love. So that sort of pushed me more into the science stream. And so about high school, I was clear, if I get a chance, this is the career that I want to go.
Wonderful.
And yeah, so then, I guess we'll come to this later on, but the planetarium played a huge
Huge.
role for me in changing my trajectory and showing me the real joy of doing science. That was during my undergraduate.
Bangalore Planetarium. That's
Bangalore
yeah.
Planetarium. Yeah, this is
Okay.
Jawaharlal Nehru Planetarium in Bangalore. Yeah.
Planetarium in Bangalore. Yeah.
This is the one that
Yeah.
Professor Steve Shishura started.
Yes. We have a lot to talk about that. We'll come to that particular point because I know it has deeply influenced you both as a scientist and also as a person who is interested in outreach. Before we come to that point, Vijay, I also grew up in Bangalore. It is actually a city where you are exposed to science, but there are also exposure to other things,
Yes.
including engineering and a
Yes. Very
huge
much so. Very much.
and a huge pressure. By the way, I
Yeah.
should
Yeah.
mention that Vijay and I went to the same college, MES college.
Yes.
We belong to the same college, and yeah, you also were a very good student. I know even ever since your college days. But there must have been also a lot of kind of pressure and also nudging among the ecosystem for you to get into engineering,
Very
because I
much so.
know coming from Bangalore, I know how
Yeah. Yeah. Yeah.
important
Definitely.
aspect it is, either
Definitely.
medicine or engineering,
Yeah.
more so for engineering. That's a default
Very-
position. And
Yeah.
here we are two Bengalurians, at least, and the former Bengalorean and the one who has lived all his life there, where we actually did not get into the
Exactly.
engineering.
Exactly.
Tell us that aspect about it, Vijay. In fact,
Yeah.
that
Yeah.
is a crucial thing, and we'll also
Yeah.
have a discussion on that. Yeah.
Yeah, no, that's important because as you mentioned, so this was like in the early 2000s, late 90s, early 2000s, and the IT boom was huge in Bangalore and Silicon Valley, Silicon City, and so on. So every Tom, Dick, and Harry wanted to be an engineer, and it was essentially software engineering. And
Yeah.
so the situation was like if you did not get into engineering, you're not good enough for it.
Good enough.
I
Yeah.
mean, people wouldn't even think that somebody would want not to get into engineering, but maybe want to pursue something else. That was unheard of, unthought of. I mean, how can you have such a thing? Yeah,
There was
sure.
there was an
Like
infamous serial Danda Pindagulu, if you remember.
Udaya TV used
Man,
to.
yeah,
It was
and
very
what a
demoralizing.
shame, what a demoralizing thing, huh?
Dandapindagulu.
BA, BSc, BCom Madi, something like
Exactly,
that.
exactly, exactly. So all the Bs and the MBBSs were doing well in life, and the BA, BSc, BComs were suffering. Yeah, true. So there was a lot of pressure, surely, unsaid pressure.
Hmm.
But luckily for me, my parents never pressurized me. So I had made it clear to them that I really would like to go in physics and mathematics, and they were quite happy about that. And all they wished for is that I just get a good job and settle down in life and pursue what I want. They were not keen on, earning several huge amounts of money and being competitive in the rat race. That wasn't there. So when I communicated that to them, they said, "Fine, go ahead." I didn't have that pressure, but they had a lot of pressure from the neighborhood, the family
Hmm.
structure. How is it that okay, I had fairly good marks in my 10th and 12th, and so therefore, how is it that you got such good marks and can go? What is this? This doesn't make sense. Have you gone mad? He probably has lost his mind because there were all kinds of comments passed around at that
Yes,
time.
yes, yes.
That's fine. I'm sure many of us can relate to those things.
Yeah, yeah. Very
That's
a lot.
fine. So that's okay. But then I mean, it's so much so it became that I won't name the college, but when I applied for a bachelor's degree, I had pretty high marks. I didn't get a seat in a college. And I was surprised. And we went and talked to the principal, and the principal said, "You have such a high rank, you're guaranteed to get an engineering seat. So why are you coming to BSc? So we're sure you won't accept our offer, so we're not offering
Hmm.
you." It was a
Yes.
difficult time to convince that person that no, 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 I actually want to go to science. So that
Hmm.
didn't happen. Anyway, MES college, and I should remember Professor Ranganaiki. She
Okay.
was the one who said, "Fine," and she just said, "Are you sure you won't leave?" I said, "I won't leave," and so she gave me a seat in case. So yeah, there was a lot of pressure, but then in hindsight, I think we made the right decisions. I
Absolutely.
think I
In
ended up
fact,
doing very well.
I was also asked a similar question, by the way. I was told that since you have this marks, why I think you
Exactly,
would not be
exactly,
not joining.
exactly,
So that is the
exactly.
state of affairs. At least that was the state of affairs. So Vijay, one of the things I really also admire about your upbringing in terms of way you have been able to work through some interesting aspects related to science from your own interest, but also a lot of stuff what you did even in the college actually was very good, in the sense it's a unique thing, because most of the time you'll see that if it's almost now a misnomer that if you want to do very well outside college, you will have to do not so good in the college. But here it was not the case, because always had a very good kind of profile. I know that there might be influence from the planetarium, but we'll come to that part of it. But I just want to know, within the schooling, how was your kind of exposure? What are the things what you really learned, so that it could become crucial for you to further your interests, And also, you have also a very good, strong foundation in mathematical way of looking at things and bringing the physical viewpoint, which is something I'm very curious to also to explore a little bit more. Could you tell us a little bit about your upbringing, especially in the schooling days, before we get into the next line? Yeah.
So I don't recall any particular teachers who made a deep influence on me. The person who made a really deep influence on me in the sciences was my father. He's a 10th dropout, but he has this fascination for mathematics and trying to understand. And it's like he lacks that, so therefore he wanted. So he would really encourage others to learn, and he would get me a lot of books. This was the time in Avenue Road. Second-hand bookstall ಸಿಗೋದಲ್ವಾ so 10 ರೂಪಾಯಿ
Oh,
15 ರೂಪಾಯಿ. So those things we would get, and I
by the
got
way, you can switch to Kannada and Hindi anytime.
okay,
ಯಾವಾಗಾದ್ರೂ
great.
ಬೇಕಾದ್ರೆ ಮಾತಾಡಿ.
Excellent. So ಅಲ್ಲಿ ಅವಿನಿಯೋ ರೋಡ್ ಅಲ್ಲಿ 10 ರೂಪಾಯಿ 20 ರೂಪಾಯಿ ಪುಸ್ತಕಗಳು ಸಿಗೋದಲ್ವಾ. Those are all books from the Russian era, or books that have been discarded, but they were absolute gems, and that made a huge difference in building up the solid base that is required there. So that was very, very good. I have also had a very good teacher in my 10th standard, not from school but from tuition, and he was
Nice.
somebody who was a mathematics lecturer, retired, and but that person really made a difference in the way he showed me mathematics from there on. So that put up basis. But I would really put my father as the one who bought me a lot of books and showed me the way to think about this.
Wonderful. So, Vijay, there is also an element of environment in Bangalore, which kind of fosters you to also develop interest in science.
Yes.
Even though there is a lot of pressure in terms of other academic kind of inclinations, were you also exposed to anything else other than the planetarium?
No, well, not much. I mean, the point being, as you know, the Tata Institute ಒಂದು ದೊಡ್ಡ ಹೆಸರಿತ್ತು ಬೆಂಗಳೂರು. That's still there. But then beyond that, people didn't know about other institutes. Tata Institute, Tata Institute is ISC, the Indian Institute of Science, where I take my PhD. But Paktale Raman Research Institute, but nobody would know that.
Yes.
So there was a bus stop, and nobody knew that there was Raman Research Institute there. So that wasn't there. I mean, this was the mid-90s. In the world was a different thing, and you could just enter into the IISc. So that was not an issue. My father used to take me there, but we wouldn't get access to labs or libraries or anything like that. But the greenery was wonderful and still is. So we just go for walks. So that sort of made a difference, maybe in the subconscious mind, that maybe I should pursue this. But I can't recall anything specific about that. One set of things that when I started recognizing that I want to be in the sciences, I started looking up the kind of institutes that are there in Bangalore and what they pursue. So the Raman Research Institute, again, made a difference for me, because I was able to get information about public lectures that they would host from very distinguished speakers. I particularly remember a lecture by Alan Aspect. He talked about Bell inequalities, 98, I think, 98 or 99. And this is organized in the Raman Research Institute, and I went there. I couldn't get anything; everything went over my head. But then it was just the atmosphere, the vibrant, the excitement, that really made a difference. And more important than that, I mean, the kind of people that one saw there. I distinctly remember Professor Enkumar and Professor Rohini Godbole. And they were really jumping on their seats and asking questions, and that excitement, the joy of discovery, that made a huge difference. And I said, okay, we should try to be at least some aspect of what they are. That definitely makes a difference. Apart from that, one didn't know of many institutes. I mean, in hindsight, I mean, one should have known about the JN Center, the Indian Institute of Astrophysics, ISI. These are not so very popular. I mean, one wouldn't see them as as possible places where one can do science and mathematics and have a good career. Unfortunately, it's still the case that people don't know them. It's only the flashy institutions that one hears of. There's so many good institutions in Bangalore, not just in Bangalore, but even throughout India. One just doesn't hear about that. That's still a sad state of affairs.
You're absolutely right. In fact, that's what, when you have too much of information, this is what also it happens probably, right? Because maybe people are not aware of the fact that there is a lot of opportunities available there.
Exactly,
That
exactly,
is another
exactly.
thing which is I also feel
The
that.
one thing, particularly parents, I mean, they should
Hmm.
know that, if a child is interested in physics and mathematics, it is possible to build a good scientific career in India. There are
Absolutely.
enough opportunities. And it's not that if you come to the sciences, you won't have a good job, you won't have a good life. That's totally incorrect. I mean, just like we had the engineering craze in the 2000s, there's a different craze now, but there is still a craze. And so therefore people don't know. One of the jobs that Indian institutions should do is to communicate the fact that you can do scientific careers in India. That's important.
Absolutely correct. Absolutely. I totally agree with you. So now tell us a little bit about the story behind your encounter and also your exposure to JN Planetarium, Jawaharlal Nehru Planetarium, which actually is one of the centers of learning which has informally influenced a lot of people across not just Bengaluru, but many different places. It has also indirectly influenced me because I was also part of some particular grouping which Professor Srinivasan was running.
Yes,
But
yes, indeed.
Planetarium was one place where I used to also visit very often.
Very
So
much,
tell
very
us a
much.
little bit. Tell us a little bit about that, Vijay. Tell us an overview because you have spent time both as a student now as a person who also interfaces with them with outreach activities. Give us a gist of that, please.
And I also teach there. I've been
Teach
teaching
there.
there. Yeah.
Yeah, yeah, absolutely.
So, I mean, we didn't know much about the planetariums. The planetarium came up in the early to mid 90s.
Mm,
And
mm,
at that point of time, the perception was more like, it's a place where there are sky theater shows
mm,
and
mm,
astronomy. And that was all there was to. There was a dome, and my mother recalls even now that when you go past Chalukya Circle,
mm,
AGS bus stop,
mm.
Kartidara dome. So we heard that there were theater shows. That was the picture. The
Right.
first time I went was again when my parents took me there. And so it was just a science show. And then there was a trip organized from the school. Again, just a Sky Theatre visit and saw the show and came back. Didn't know about the educational activities there.
Mm,
It changed in the year 2000. So I saw an advertisement for a summer program to be held at the planetarium. So this they hold every year.
mm,
And then there was a statement that for this is designed for students who are taking up research, who want to take up research careers, and who are going into science engineering at the undergrad level. So this was in 2000 summer, 99 2000 summer. And so I applied for that and I went there, and that's where things really changed for me. I realized that there was a totally different aspect of the planetarium, which is not so well known to the public. And this was, in fact, initiated by Professor Vijaykumar, the
mm.
vast non-formal science education enterprise that he built. And that's when I started encountering. And to surprise, the first person who gave the lecture in that summer program, Professor Enkumar,
Nice.
deterministic chaos. And he talked
Mm,
about dripping water faucets in Bangalore. And that was
mm.
an absolute gem of an
Gem.
experience. So there was Bala Iyer who talked about gravitational waves, C.V. Visheshwara on generativity. And there were a host of people from RRI, JNC, IISc, Astrophysics Institute. And they gave very fascinating lectures on. I mean, it was just to expose people to cutting edge science, to give them a feel for the kind of things that happen. It was totally different, right? You would never get this experience in school and college. Never ever. I mean, that was amazing, absolutely fascinating experience. That's something I'll never forget in my life. And that's when I also discovered that they have these non-formal science education programs. And that's where many people were getting trained. So, I mean, it was a no-brainer. I just decided to join. So I spent I would spend weekends there, Saturdays and
Mm,
Sundays, almost all of Saturdays and Sundays there for a complete 3 years. There were lectures apart from the summer lectures, there were regular long-term courses. Lectures were given by Professor Bala Iyer and Professor S. Lokanathan.
mm.
Professor Lokanathan passed away recently,
Very recently. Yes,
very
yes.
recently. So he was a great influence on me. So they taught and they laid the foundations for me in physics and mathematics. There were also lectures by Dr. Beera Sharaja on
Mm,
astronomy,
mm. Astronomy.
and they made a huge difference for me. And more importantly, H.R. Madhusudan.
Madhusudan,
He
yes.
completely changed the picture of science that I had, and interactions with him over the past 25 years. I mean, he has shaped my thinking and he has shaped my perspective of science. So I was part of the school there. I was part of the training that happened on weekends. I would be eagerly looking forward for the weekends, because that was when you would really have fun in science. You would solve hard problems, discuss things. There was a small group of people interested. We would sit down, chat late evenings on the stairs of the planetarium, and that made a huge difference. Particularly, it made a difference, one, in laying the solid groundwork in physics and maths. Second most important thing, which in hindsight I realize now once you are in a professional career in sciences, it opened up networks. It gave you connectivity to scientific institutions. It got you in touch with scientists, and with a backing from the planetarium saying that, okay, this boy is good, you should take him a bit seriously. People would allow me into their labs, into their groups. That really changed the game. Changed the game. One particular thing that really made a difference was I did a summer project with Professor K. Nagendra in the Indian Institute of Astrophysics. And he was working on radiative transfer. And so I did a summer project. This was just after my first year BSc, so I barely knew any physics. But he was kind enough to, gently guide me to read semi-popular, semi-technical things. And so I got some sense. I worked on spectral line broadening and astrophysical plasmas in the Indian Institute of Astrophysics. That made a huge difference. Because, once you did that, you were able to broaden your networks. You would get to know more about the kinds of different physics that happens there. And backing from the planetarium then opened up a host of opportunities, because the next summer I got to work with Professor Enkumar. That was a dream come true. I had heard him like 4 or 5 years ago, the Alan Aspects lecture the first time. And that really changed the way one thinks about physics. Enkumar, I have never encountered anybody like Enkumar apart from him. It's the intuition that he would bring to physics is just brilliant, absolutely brilliant.
Remarkable.
I'm absolutely fantastic person. Can you draw a Gaussian? The Gaussian already. That was amazing to think about. Right? There are two spins interacting like this. A spin already point out to the So the intuition that you would bring to thinking about physics was unmatched.
You could see, in fact, I used to also attend some this journal clubs in RRI.
Yes, RRI journal clubs.
And he used to be, he is the director of the institution.
Sit in the front.
Sit in the front.
Yes.
It's not just only discussion, it's also the enjoyment of learning and also interacting about physics and then particularly. Marvelous. It's a great impression for a lot of young people who will be watching.
They have an infectious enthusiasm for science.
Absolutely.
Absolutely fantastic.
I have to also mention, in Masters, I did my summer program with Professor Nagendra. Unfortunately, Professor Nagendra is no more. In second solar spectrum and other aspects of
wonderful.
Yeah. In fact, Professor Nagendra has also influenced deeply a lot of people.
Yes, very much. Many
from universities. He also used to come to Bengaluru University and teach.
That's correct.
Professor Kagli, Professor Jayant Murthy, a lot of them actually did a lot of interesting stuff. And they've all played a very critical role in putting the scientific landscape on the map in the sense that's very important.
Exactly.
Vijay, tell us a little bit about that model of planetarium. Mr. Madhusudan is somebody whom I have very high kind of regards. I really have very high admiration. He's played a critical role in enthusiastically supporting so many people. I've heard this
hundreds of people.
Yeah, hundreds, maybe even thousands, probably, because there's so many people who have influenced.
The multiplicative effect. I mean, many of them have become teachers, right? So
exactly. So give us a flavor of that model system, because as I told you, have been both as a student and now as a teacher and a very close collaborator of Planetarium. Give us that just before we move forward.
Yeah, sure. So what I gather is this is essentially Professor C.V. Vishweshwara's brainchild. So he had this thought of setting up the planetarium, and he also had the thought that the planetarium should not be just something which caters to the general public about science lectures or sky theater shows, but should also be a venue where non-formal science education happens in a very rigorous manner. So his idea is, I think he brought it to fruition somewhere around the 2000s, late 90s, early 2000s. The precursor of that, I've heard, is that Professor Bala Iyer used to teach interested students in MES College, our alma mater. So he would just go over there on Saturdays and Sundays, and there was no formal structure or anything like that. He would just go and he offered, I'm ready to teach. And there were a couple of people who just would sit and listen to him. Then Professor Vishweshwara took that structure and said that why don't we make it a formal thing, and bring it into the planetarium. So Professor Vishweshwar's ideas is that he has this very nice structured organization. So I very strongly encourage everybody to. There's a nice video on YouTube. Just before a couple of years, he passed away. So Vishweshwara was asked to give a talk on gravitational waves again in MES College. And there, after the talk, there's an interaction session. And in the interaction session, he actually spells out the structure of the planetarium. So I'll just repeat what he said there. So he has this thing called SEED, Science Education in Early Development. So this is like middle school and maybe middle school to high school kind of a thing. Then he has SOW, Science Over Weekends. This is like high school and 12th and PUC and things like that. Then he has REAP, Research Education.
Yes.
It's like a seed, sow, reap.
Wonderful.
Kind of
Wonderful.
And I mean, if you look at the kind of vision that he had, this is just absolutely remarkable. So I gave a talk in ICTS when we were celebrating his work, remembering C.V. Vishweshwara. I dug up a lot of material with planetarium friends, and there were newspaper clippings from the early 90s, mid 90s, where he has given interviews to journalists, and he has sort of put out his idea. I mean, he had a plan that he wants to attract children in their middle school and have a pipeline all the way up to their BSc degree to sort of inculcate scientific ideas, scientific temper, rational thinking. And his idea was, this is the way to attract the masses, funnel them through this very rigorous training procedure, and push them into research careers. That's amazing. I mean, he built this for like 25 years, and over 25 years, we have close to like 200, 250 people who have passed through the planetarium and have become faculty in India and abroad. So it's come full circle, and many of us are going back and teaching there. So this structure is something that he built very, very nicely. I mean, he used to emphasize a lot that, Indian education, perhaps even now, most of it is rote learning. And he himself used to emphasize that how he struggled when he went to the US for his PhD. He was, destroyed in a few days because everybody was good at problem solving. He was good at write an essay on general relativity. But that's not how you do science. So you have to relearn all those things. And that experience he brought and to the planetarium, and he conveyed that this is the kind of training that one should get. And so it was really his vision. And of course, the support by Professor Loknathan and Balayar is absolutely crucial. Without them, nothing would have gone through. So this structure that he put up of seed, sow, reap is really what's the non-formal science education system that's there in the planet. It's not a formal degree. I mean, at some point, he would make a statement that, look, if our undergraduate education system was very good, there would be no need for a REAP program. So because people in the usual undergrad systems don't get exposed to research, don't get done things very rigorously, there is a need for such a program. That's where he has actually built to this part. Yeah, so after coming back and joining ICTS, I've been teaching there from the past 7-8 years now as well. So it's very nice, it's very heartening, because many students who come there, come on, you don't have anything else to do on a Saturday and Sunday, you come and want to do mathematics, you must be genuinely interested. Right? I mean, of all the things that's available in a city like Bangalore, if somebody is ready to come and sit on Sunday morning, 9:30 and listen to mathematics, well, they must be really interested. So it's only such people who survive the 3 years, and many of them, there's a continuous stream of people going to PhDs and then eventually settling down in science. There's a huge number of them.
Yeah, Padma Priya and so many of them. Even I know many of them. The other aspect, Vijay, is, this is a beautiful model. Thank you very much for bringing this kind of, structure to that way. It's a great model to emulate even now, across country, because it also doesn't disrupt the system quite a lot.
No.
Yeah, that is the beautiful thing about it. But there's also this element of freeness of thinking, freedom for thinking.
Exactly.
Because most of the time, having also been teaching undergraduates now for several years, students are always under some kind of pressure when they're taking a course, because there are so many things around the course also.
Exactly.
Because even if they're genuinely interested, the amount of time they can spend would be directly related to the examination and other kind of evaluation.
Precisely.
This can become kind of an outlet for them to explore things without having to be always mindful of the fact that they'll be judged at the end of the course or something like that.
Exactly. So one of the things that really makes a difference in the planetarium is the following. They also have labs. So it's not just
Yeah,
classroom.
yeah, you're right. Yeah.
And one of the things in the labs is, unlike college things, there is no aim and what you have to get as the result. It's open-ended. Go to whatever you want.
Yeah.
So that sort of, gives you a flavor of research. One of the difficulties when people come to research is in your undergrad, school, college, master's, somebody asks you the question and you're supposed to write the answer. In research, your job is first, what is the question?
Yes, absolutely.
Just finding out what is the correct question is half the job done. And so therefore, if you don't get that flavor right from your undergrad days, then you're sort of, in this mode of what's the assignment problem that I have to solve? No. In research, you have to set the question and you have to answer it. That made a difference in the planetarium. So there wasn't something like solve this and solve that and get the marks. What is the correct way of thinking? You develop it yourself, be it in theory, be it in experiment. The open-minded experiments that would be there, Matsudna used to manage them and still does, that would be a huge deal breaker, because it's not like you have to get 9.7 for gravity. Huh? It's okay if you get 12, that's fine, but please understand why you got 12. What was the reason why you got 12? Maybe there are errors. It's one way to understand errors. Something went wrong with the experiment. So this way of thinking and exploring, that's a huge difference. We still lack that largely in the Indian system. There are only pockets here and there which are good. That's something which should make a huge difference.
Beautiful, beautiful. One of the aspects, since you also mentioned, and I was kind of recollecting, most of the time I have met you, even though we were in the same college, the time I have met you was in RRI library, That's the place I used to actually always, meet you. And,
You're right.
that is also a time where you probably were also kind of interacting with Professor Enkumar. And I want to talk about one particular aspect which I think is very deeply impressive. Vijay was an undergraduate student, and he did an outstanding kind of a piece of work with Professor Enkumar, where he was thinking about classical angular momentum of light, which is an area which I am deeply interested, by the way. This dates back to early 2000s, where Vijay was an undergraduate, and he was thinking about this particular problem of angular momentum of light from a classical picture. He also actually looked into some elements of a paradox, and kind of went on to look at the resolution of that particular paradox. Give us a brief background to this. I'm going to give this reference in the show notes and the references, but give us a gist of this.
So like I said, so in the planetarium, Professor Balayar was teaching vector analysis in the first year. And so it turned out in the second year, he had to teach something else, special relativity or something, but he had begun electrodynamics in Griffiths. So I requested him if I could work out problems on my own and maybe come discuss with him once a week or twice a week. And so learn electrodynamics on my own. And he really kindly agreed. And so I would go meet him and learn. So by the end of the second year, I had more or less finished Griffiths. So I had a reasonably good background in electrodynamics. So when I got a chance to work with Enkumar in the summer of 2002, he asked me what do you want to do, and I hadn't done quantum mechanics by then. So I said electrodynamics is something that I've done, and he thought about some problem, and he asked me, have you seen ideas about momentum and angular momentum stored in light? And I said, yeah, okay, I understand pointing vector. Then he put a puzzle to me, and that was completely stumping. And so he said the following idea. So let's say you have an electromagnetic wave, a plane polarized electron. Okay. So then you have the electric and magnetic field, electric and vectors like that. Okay, fine. So, but then what's the momentum? E cross P with some C square on there. What's the angular momentum? R cross of E cross P. Okay, fine. But then he said, let's take a circularly polarized line. Okay, so then they're going like that, left. So then he said, calculate the angular momentum. Okay, R cross E cross P. And then lo and behold, it turns out to be zero. But then circularly polarized light does have angular momentum.
Angular momentum, absolutely.
So where did this go? I mean, so how can, I mean, it's an exact statement. So then he asked, where did it go? I mean, it was completely puzzling. So where is that? So in the quantum mechanical picture, photons do carry angular momentum. So why is it not there in the classical picture? So he showed me something very, very, very subtle. So he said that, we can do an exact calculation in the following sense. That's like a cylindrical waveguide. And in the waveguide, you can actually solve Maxwell's equations and get the electric and magnetic fields exactly. But being a waveguide, the electric and magnetic fields will satisfy some boundary conditions, right? So it's a conductor, so the electric field vanishes, tangential, something, whatever. And then he said, let's calculate the angular momentum now. and it turns out to be some non-zero number. And then how do you go from a bounded, transversely bounded system to a unbounded monochromatic plane monochromatic? Well, just take the radius to infinity. Okay, so first do the calculation of the angular momentum and then take the radius to infinity and see if it survives or not. Lo and behold, it does survive. It's a finite value that, so then you worry, where is the angular momentum? So you can actually show the angular momentum is zero everywhere in the bulk except on the boundary.
Except on the boundaries.
Okay, so as you make the boundary go to infinity, the angular momentum density goes to zero, but the R goes up, right? The momentum density goes to zero. Sorry, beg your pardon. Momentum density goes to zero, R goes up, so the product remains finite. So for in this limit, the R cross of E cross B remains a finite number. And the interesting thing was he asked me to calculate the energy flux as well, and then take the ratio of energy flux to angular momentum in the Z direction. And that turns out to be 1 by omega. Right? Nice. So that's a quantum mechanical result too. So you have NH bar omega and NH bar. And so they will cancel out and the ratio is just omega. And so this comes out even classically. So you can show that the ratio of angular momentum to energy is essentially 1 by omega, which is true both classic. So that was a very, absolutely fun calculation too, because it was based on, electrodynamics, waveguides, things that I could do comfortably, but ask some very deep question. I mean, the way he posed the question, what is the angular momentum of light and why is it zero? As if you do a naive calculation. That was an absolute gem of a calculation for me to explore.
Beautiful. Beautiful. In fact,
being Enkumar, he connected it to many, many other aspects where subtle effects of boundaries play a role in the way in which bulk physics comes about.
Beautiful, beautiful. It's a kind of tribute to the way physics is done in the right spirit. It's a beautiful way of looking at it. It also has turned out to be a very important problem. In fact, it's not just only the curiosity, and that's another reason why curiosity-driven questions are so interesting. Because as I speak, even today, the angular momentum of light and the structured light per se, which is now the umbrella of the larger picture, is still an area of research which is giving out questions, which is beautifully kind of positioned, both classically and quantum mechanically, by the way. There's also a lot of stuff related to that. So,
since you mentioned the RRI library, I want to say something about that. So that's probably one of the best libraries I've seen for learning. If you want to learn physics, and it owes a large part to the directors of RRI, before Kumar and Professor Kumar himself, and the choice of books, the kind of pedagogical ideas. There used to be so many books on paradoxes, brain tweezers. That's the way you learn things.
Absolutely. It
was brilliant collection. Absolutely brilliant collection. It still is one of the best libraries that I've seen.
I actually completely agree with you because I've also significantly spent a large part of my undergraduate time in that library, thanks to Professor G. Srinivasan and G.S. Ranganath, another fantastic person, optics, soft matter, etc. And also a lot of people in the community where I used to also kind of interact a little bit with others. But that environment and very precisely what you mentioned is there are books around physics which actually add a lot of value to understanding of physics. I remember still the Wheeler's gravitation book, that big book that used to be there. A lot of PhD students used to actually probably refer to that for some reason. Although if you look at Chandrasekhar's mathematical theory of black holes and Wheeler's gravitation book, they probably actually have a different viewpoint because one is very pictorial and other things.
Mr. Thorne Wheeler, MTW, was called the phone book. That's
the thing. Exactly. So, Vijay, having got this kind of very wonderful exposure to some fascinating aspects of physics, I'm sure this is all coming through a lot of interest. But one also has to do a survivor kind of thing because this is a question a lot of undergraduates usually have, and also even for that matter PhDs have. There is an element of balance because you would have to get exposed to a lot of interesting things which are happening in physics, both contemporary and the foundational principles. And the other thing is also you have to do your courses, you have to really do things. I would ask this because I know firsthand that you did very well in both these things. What was the way you approached these things? This is something which probably is of interest to a lot of people. How do you really balance depth and breadth?
Yeah. I mean, I don't know if I did very well. I struggled in the college work because
Hey, but
it
you
was,
you, you did actually get good grades, huh? I
yes,
remember.
yes.
I
Yeah, but there was a bit of a struggle, to learn things
Mm.
in a different way. Yeah, but then see, I mean, at the end of the day, if you the system is whatever it is, you must make sure that you survive in the system. Otherwise, the other thing, the curiosity and all won't survive. I mean, this won't go away. It's not just at your undergraduate level.
Yeah,
You, as faculty, we know we also have to do a bunch of things. We are
yeah,
not so
yeah,
interested,
absolutely,
but
absolutely.
can't help it. I mean, the
Yeah, yeah,
system is
absolutely.
like that we have to keep things running and the wheels chugging. So therefore, you have to do that part of the story. But the point of being a scientist as a career is that you get a significant chunk of time to pursue just what you love.
Yeah,
That is
absolutely.
amazing. That's just brilliant. I mean, there's the chore aspect, fine, but that's there in every profession. But then a significant part is not a chore. I mean, it's play. And nobody has to pay you to play, but they do pay you to play. So
Yeah.
that's amazing.
Absolutely, absolutely. Now, this is something which is very critical, and the fact that students do really have a lot more options nowadays. There are very many avenues. For example, there was no YouTube. For example, we probably are
Exactly,
covering,
right? Exactly.
and especially when it comes to three-dimensional visualization, and in
Yeah,
certain cases, multi-dimensional
yeah.
visualization, and also the way mathematics is being taught and learned. I wish I was a student now
Me
because
too. Me too.
right?
I mean, once upon a time, there was a lack of resources. Getting good
Ex-
books,
yeah.
getting good connections, and finding out references, getting articles was a big deal. You wouldn't know. Nowadays, there's no dearth of that at all.
In fact,
Absolutely no dearth.
the problem has gone on the other side.
Exactly. It's the other way around. There's too much stuff. Too much
Too
stuff.
much, too much stuff. So this also segues to the aspect of your kind of slow interest into the areas of research which has developed into your own kind of expertise. Before that, I want to talk about a little bit on the transition, because you're doing all these things undergraduate, and now you are kind of crossing the road, so to speak, from CV Raman Avenue to
Yeah.
across the road into Tata Institute. Tell us
Yes.
a little bit about that transition.
Yeah. Yeah. I mean, okay. I first met my PhD advisor, Sriram Ramaswamy,
Hmm.
when I was a summer student in RRI. So 2003, I got a chance to work in the RRI summer program with Professor Yashodhan Hatwalni.
Hmm.
So Yashodhan was a student of Sriram. And at some point, we were working on some problem of rheology of active materials. I didn't know anything about active matter. It was just an exposure, but that was all that was required at that point. But Yashodhan was kind enough to sort of take me and introduce me to Sriram.
Hmm.
And that made a difference because Sriram's voice,
Oh man.
first time I heard, itself made a
He's mentioning to Professor Sriram Ramaswamy,
Sriram Ramaswamy,
one of
yes.
the pioneers in soft condensed matter, and of course, he any paper you'll read related to active matter, there
Yeah,
cannot be a citation without Sriram's work.
that's correct. That's correct.
Yeah,
That's correct.
yeah,
But active matter was not at the peak at that time. This
yeah,
was
yeah. You're right.
2002, 2003.
Hmm.
Sriram had just written the paper with Aditi in 2002 in
Hmm.
PRL. But then, I mean, at that point, I didn't understand all that. The thing that made an impression for me was Sriram's voice
Hmm.
and the excitement and the jumping around he would do to explain physics. That sort of is an infectious thing. So that made a difference. And luckily, I got into the integrated PhD program at IISc. By then, I had a sort of an inclination that I want to go to biological physics. At this point, I should mention that Enkumar showed me some fascinating aspects of biology. I mean, just when you're having a cup of coffee or something, he would ask questions which were, stumping. I mean, does it mean physics doesn't apply to living systems? I mean, Newton's laws don't work in cells. How can that be possible? It set you thinking about these kinds of questions.
Hmm.
I also got an opportunity to interact with Madan Rao, Professor Madan Rao.
Yes, yeah.
He was at
Another
that time
stalwart. Yeah,
another
yeah.
stalwart, and he was transitioning to biology. He made a transition to biology. And I have actually documented this in my thesis. I hated biology in school. I mean, the way it was taught was just mugging up and rote learning, and that was not the kind of thing that fascinated me. And even now, many people, who don't like mugging up, go to physics and math. Who don't like doing math, go to biology. But then I was just one of them who did not like the mugging up aspect. But Madan gave me a totally different view of biology, absolutely different view of biology. And the way he posed problems in statistical mechanics and soft condensed matter and showed that living systems, are really manifestations of this in the driven non-equilibrium regime was absolutely fascinating. And that sort of made a deep impression that, it sort of connects the things that you see in the sky and the things that you see your cat running around. Questions about, are they the same laws of underlying both of them? And somehow this is not taught in one courses, this is taught in other courses. There's no connection between them.
Correct, yeah.
Madan painted a very beautiful picture for me. That made a huge difference. And so I kind of sort of switched gears and more or less decided that I should go to biological physics. I didn't have a good grip on the area. But then Madan also advised me that if you want to do good in biological physics, your physics must be good. So therefore, first do your physics PhD. And so I decided IISc. Luckily, I got into IISc. And I also went to TIFR. So since I'm a faculty at TIFR, let me just say that out right now. So that was the first time they were actually becoming a university, TIFR. The first time they were admitting integrated PhD pro students after BSc. So it turned out that I and Vijaykumar, the other person that you interviewed.
We He's been on Pratidhwani.
Yes, we both went to the TIFR interviews in physics. We had a fun experience. I don't know if Shivu recollected that. We had a train accident. We fell down, hospitalized.
Oh, man.
Oh, yeah, we had all kinds of funny things another day. So it turns out that the interviews went well. We got into that as well. And TIFR being TIFR made the offer very early and also put the deadline very early, much before even the IISc entrance test happened. So what do? I mean, so then I just said yes to TIFR. I accepted their offer. But then I also got to IISc and then I said no to TIFR. So now that I'm a faculty at TIFR, let me say this now.
Yo, man. Who was it? In Bombay, right? In TIFR Bombay?
It was in Bombay. Pushan Ayub was the graduate self coordinator. And I had a couple of email correspondence with Professor Sunil Mukhi.
Okay, nice.
He was the one who I wrote to saying, sorry, as you see, I got into IISc as well. I had to cook up some reason. And then I said, my hometown is here, so I'll just stay here. Sorry, I can't accept the TIFR. Anyway, so I got into IISc physics, and that was a huge difference, right? Because the kind of people that are there in the IISc physics department are really stalwarts in condensed matter physics.
Yeah, absolutely.
And that really gave a rock solid training. It was hard. The PhD is always hard. But then the kind of training that you would get in the courses there is unmatched. And more or less, I had decided that it has to be Sriram, else I'm leaving IISc. Luckily, Sriram accepted me, and I did a PhD with him.
Wonderful. A lot of us, for example, in my own case, I did my coursework in IISc. In fact, one of the most important courses during that time was Balram's spectroscopy course and Sriram's soft condensed matter course. Exactly. These are two courses which were highly subscribed. And although a lot of people from various different backgrounds took, for example, Balram has a very, very strong background in organic chemistry. And but yet a lot of physics students used to take, because he used to learn a lot. And of course, same with Professor Sriram Ramaswamy, his booming voice, which could be heard outside the building almost, so to speak. So Vijay, I would want to get into the questions which you were interested in during the time of your integrated PhD kind of thing, and also the evolution of those questions and the interest what you have developed since then. Give us a gist of that.
So with Sriram, I worked on one problem which was on some aspects of molecular motors. That was the closest that I went to biology with him. It was mostly about Brownian inchworms and how self-propelled motion can happen. The motivation was really understanding models for molecular motors. Molecular motors are these tiny things that exist inside cells. They move on tracks. And the fact that I'm moving my hands, the muscles are operating, and it's really because of the action of these molecular motors there. So we worked on a small problem trying to understand how internal asymmetry could give rise to self-propulsion there. One of the major problems that Sriram gave me was trying to understand the kind of apparent divergence in velocity fluctuations during sedimentation. Sedimentation, I mean, a familiar problem we all know. You'd say, take a glass and put something, it'll settle down. There are some subtle aspects of how the velocity field that the fluid and the suspension takes up, and how that the variance in the velocity field scales with the system size.
System size, okay.
So that's intimately connected to the structure factor of the suspension, the suspended particles. So that was the problem that Sriram gave me. So I learned some aspects of lattice-Boltzmann, fluid dynamics, non-equilibrium statistical physics, and tried to do a calculation for that. But then that ended up in my thesis. We haven't published that at all. But nevertheless, I mean, that was a hard problem. It taught me things in quantum field theory, renormalization group. Sriram held my hand and guided me through all those aspects very, very well. That made a difference. So I didn't do much of active matter or even biology at that time, but I was building up to do that aspect there. So it was mostly on non-equilibrium StatMech. I soon realized that biology is non-equilibrium. So if you are at equilibrium, you're dead. So you better learn equilibrium StatMech very well, and also learn non-equilibrium StatMech. And so therefore, who better a master than Sriram to learn non-equilibrium StatMech from? So one learned that. And then I decided that one should make a transition. It was only during my second postdoc that I really made the transition to the biological physics. At that point, there were books that really influenced me a lot. At that point, whenever one thought about soft matter or biological physics, it was mostly about membranes. For example, Ram and Madan were working on those aspects. There was aspects of active matter, whether it was flocks and schools of birdfish collections, these kinds of, that was the kind of stuff that we had. One book that made a difference and has set the tone for what I do throughout my career is Biological Physics of the Developing Embryo. This is Newman and Forgax. And this was a book in the IISc library. And strangely enough, it was in the biology section. The physicists won't frequent those parts of the cupboards and jazz. I went there, I looked up this, and then I read that. I didn't understand much of it because development is something which was not, I didn't have a clear picture of what is development, because most of the thing was about cells and, proteins and individual molecules. But this aspect of massive changes in shape and size and form and function during the development of a multicellular organism, that wasn't there. That book by Newman and Forgax made a huge difference. And particularly the kind of language they developed. It was mostly based on, macroscopic physics, viscosities, surface tension, adhesivities, frictions, diffusivities. And they would phrase the language of these are the kind of mesoscopic parameters that one should use to think about development. It was semi-technical, semi-qualitative, but then the ideas were really, really deep. And that book made a huge difference. And I began to dig up, and I found development to be absolutely fascinating. Absolutely fascinating. It's more or less coming into the picture that one should do development and do physics of developing systems, developmental biology, cell and developmental biology. Incidentally, that book, that is the book I discovered Professor Vidyanand Nanjundayas. So he was somebody well known in IISc, but he was in the MRDG department, in the molecular reproduction and developmental genetics. In the book by Newman and Forgax, they actually thank Vidya for deep insights and the physics-biology interface. I didn't know those things, that there were actually people who were at the physics-biology interface who had long back even in IISc. That made a huge difference. Nice. The other book that made a difference in the IISc library was Stephen Vogel's books, a series of books.
Yes.
Cats, paws, catapults, so many of them, the physics of living organisms. There were so many of them. And it so turns out that I didn't know about this again. It was Vidyanand Nanjundaya who invited Stephen Vogel to write a series of articles in Current Science.
Yes. Wow. Okay. This is
absolutely fantastic. Absolutely fantastic set of articles. And those articles, eventually, many of them became books. And now he has a book, a big collection, quantitative bioscience or something. I have it. I forgot I read this part. This is amazing. This is really the physics and math behind living organism at the organism level.
Nice.
So those two things made a huge difference for me. And so eventually it told me that maybe I should make a shift to biology. Yeah.
Wonderful. This dilemma always exists, even now, as of now, because ISET Pune has also a strong component of biology and physics trying to come together in one way or the other, where students are generally interested in looking at this as a possible careers for them to jump in. Uh, in at the level of graduate and undergraduate level, what are the things generally which are necessary, Vijay? Because if you have certain kind of background, let's say if a physics student wants to get into physics of life kind of questions, what are the kind of background training, or what kind of interest they should develop? Background, it's a very fascinating area. It's probably the best time to do biological physics, if I'm right, because I have kind of very peripheral connection to it, but I see there are so many questions which are so fascinating. And can you give us a gist about that?
I mean, I think one should have a strong grounding in physics and mathematics if you want to do biology, modern biology. That's my take on the problem.
Yeah, yeah.
I think biology presents perhaps the hardest problems in physics and mathematics. And so if you're really, fascinated by wanting to solve complex problems which are really hard to solve, come to biology. Biology is mathematics' next playground. There's no doubt about it. Just like astronomy and maybe the other aspects of the natural world, where we build physical models, we build the mathematics necessary to solve those models. Biology is the next playground. Living systems are the next playground. To get into something like physics of life, one should have a solid grounding in physics and math at the undergrad level, at the master's level. Perhaps more important is to have an open mind. One shouldn't get swayed by thinking that, oh, these are living systems, and that doesn't make sense. I mean, nature doesn't make distinctions. This is physics, this is biology, and blah, blah, blah.
Absolutely.
And as the job of a scientist, your job is to explain the natural world. You choose which part of the natural world you want to work on. That's fine. So if living things fascinate you, the process of life fascinates you, fine. And maybe there is one way of looking at it which is traditionally adopted. Maybe there are other ways to look at it. Maybe there are ways in which, you built telescopes and microscopes and sent rockets and understood the non-living world to such a great extent. Maybe that kind of a training, that kind of a picture of understanding living world, non-living world is also useful for the living world. Why is it not possible? So one should just get grounding in physics and math, keep an open mind, just get fascinated by the kind of processes that happen in life. It's a kind of a philosophical thing. You're sort of exploring yourself. How is it that you are made? How is it that you're working? That makes a huge difference to go around it. So there's this revolution going on from the past 20 years, 20, 30 years all over the world, and trying to understand the physics and mathematics and engineering and computation behind living systems. And so there's efforts throughout the world in trying to build programs that will explore this interface. And the number of open problems, the number of challenging problems is just unimaginable. And the scale and the complexity of the problems is just bewildering. I mean, I sort of make a joke. We perhaps understand the physics of black holes far better than we understand the physics of cells. Right? So something that's 4 billion, 3.5 billion light years away, whatever, we can measure things very, very accurately. But trying to understand physics of why a cell divides, why a cell moves, how a cell senses, we're still lacking there. We really don't have that kind of a grip on the physics. So it really presents absolutely fundamental and challenging problems in the sciences.
Yeah. Beautiful, beautiful. In fact, it's such an important point what you're mentioning. There are so many unresolved problems which actually have to be framed in the viewpoint of a physics problem, and that's where the frontier is, if I'm correct. And there is scope for a lot of people who would want to also interface with the biological kind of world and an experimental world also simultaneously, right? Because you can verify a lot of things.
Yeah. I mean, you can't do science without experiments. It's impossible.
Yeah.
That doesn't make sense at all. So therefore, I mean, bringing in the kind of physics experiments or the way you interrogate a system experimentally in physics, that kind of an approach to interrogate living systems will really reveal a lot. I mean, at some point, I think Darwin had made a statement about the role of mathematics in biology, and he says that they have a different mind. So that's kind of a way of formulating, measuring things, putting in numbers, seeing patterns in those numbers, building models to mathematically understand those numbers. And you repeat this process across many, many systems. And possibly there'll be some general features of those models that you'll pick up. And maybe that'll become a rudiments of a theory for a subset of the processes that one is interested in. So experiments, quantitative experiments, absolutely crucial. So when one says physics of life, absolutely no statement about it being theory only. You must build theory and experiments, and they should talk to each other. Very, very strong. That's the way to implement this system.
Wonderful, wonderful. So we will now go through the journey all the way from your PhD level, because during this particular time you got this great exposure, and then you also went to other centers of learning which were very deeply embedded in these kind of questions, both at Yale and also at Max Planck in Dresden, if I'm correct. Yeah.
That's correct.
So give us a gist of that experience, and then we'll shift to ICTS and the questions there.
Sure. So after my PhD, I got a chance to work at Yale. So there I was not sure of biology so much or not. Okay. There was this inkling whether it is ready, it's a field worth pursuing. There I went to work on the physics of glasses, jamming and things like that. But I very soon found out that's not my cup of tea. So I got out very quickly. And I got a job in Dresden. So in Dresden, there is a fantastic system where two Max Plancks, the Max Planck for the physics of complex systems, and the Max Planck for cell biology and genetics, these two have a very, very tightly connected network. Particularly the biological physics group of Professor Frank Ulischer, they interact and collaborate with almost all the groups in the cell biology and Max Planck, cell biology and genetics Max Planck. That environment made a huge difference for me. So I was sort of a sandwich postdoc between the two centers, two Max Plancks there. And that really made a difference because, I would get a chance to go sit in a wet lab, biology, every day, but then keep working on physics, keep working on theory, keep working on active matter, pattern formation, and so on. But then it's a slap in the face. You can do all that. You just go to the next room and there's a microscope and the living cell is building itself into showing some pattern. What are you doing? You should explain those kinds of problems, right? So that's sort of a realization of being grounded in experiments. Doing theory for theory's sake is one thing, but doing theory to explain the natural world, to explain what can be measured is a really hard challenge. That really fascinated me. So the environment there of looking at biological problems as physics problems, as problems in physics, math, engineering, computer science, bringing a quantitative aspect to that, building theory, experiment interfaces across all scales of biology. Those institutes are predominantly at the cell and molecular cell and tissue and developmental levels. But then there are other places which are building things at the ecological and evolutionary levels and neuroscience levels and so on. But this aspect of, it went back to Newman and Forgat's biological physics of the developing embryo. CBG, the cell biology in Max Planck, is a fantastic place to do development. So there I got the exposure. I learned. I struggled for a year or two because the language is different.
Yeah.
So you'll feel lost. You feel like you're useless. You can do things which don't connect to what's being measured out there. One has to patiently wait, sit down, learn the language, and then, go back and forth and translating that into physics models, mathematics equations, going back and saying that into what is measurable, what can be calculated. That experience made a huge difference for me. Possibly I had one of the best times in my life in Dresden. The 3.5 years I spent there. Absolutely fascinating experience.
Nice. See, that's also a great model for many institutions. It's a different setup, but there's so much to learn,
Very much. Absolutely.
It's a fascinating thing. So now the transition back to India. First of all, why and how?
Why there was no other option. I never had at any point of my life, I never had the thought that I should not come back to India. For whatever reason it be, it's useful to go out, get some exposure, get some training, see how the world does things differently and bring back some of that expertise back to your country. It was quite clear that I never had the thought of not coming back to India. If of course I didn't get a job, then I wouldn't come back to India. But then I never had the picture that I won't come back to India. That was always clear. I was also clear that I would come back somewhere in South India. That was also reasonably clear to me. But where was not clear. So then towards the end of my postdoc years, I started thinking of applying. NCPS was one option that I had. ICTS, I never thought of applying. I mean, ICTS had just begun when I was finishing PhD in IISc. And I think they had one conference, Frontiers in Condensed Matter Physics in IISc, in which I was a student volunteer.
Mm-hmm.
But then the kind of meetings that were being done, and I mean, the background of the people, I never thought biology would be, or biological physics would be something that would gel. So I never paid attention to that. I just left it out and I went ahead. But then when I was thinking of coming back, several colleagues told me that ICTS is thinking seriously of building a group in biological physics, and you should think about that and apply and think about it seriously. So then I applied. I was lucky. I got it, and I've been here.
Wonderful. Wonderful. So a couple of kind of brief aspects related to both ICTS and also the initiative Copy with Curiosity, which is something I'm very fascinating to learn more about. One is ICTS model is also unique to an Indian system in the sense they have very interesting programs, which is very offbeat from the conventional systems, what is generally available in other institutions. You can give us a gist about that. And second point is also your kind of brainchild, the Copy with Curiosity. And over the years, some outstanding people have actually really, participated in that, both as speakers and also, intercolators and things like that. Give us a gist of both these things.
Yeah. So first, ICTS, I hope I do a good job.
Yeah.
No, my director doesn't catch me.
No, you can be informal, just a gist. People, I would, of course.
ICTS is a three-pronged mandate. One is in-house research itself in various areas of physics, math, computer science that we're planning to grow, and biophysics. That's the aspect which is common to many other research institutes in India as well. The second mandate and the major mandate is to act as a hub for organizing meetings. So the inspiration is centers like the Kavli Institute of Theoretical Physics in Santa Barbara, the classic International Center for Theoretical Physics in Trieste, or the Newton Institute, MSRI, many of these places where they would act like a place where people from different parts of the world would come, organize a meeting, discuss freely, and the host institute would actually, provide all the facilities to running the meeting, secretarial help, logistical, financial help, and all details of organizing the meeting. There is a team that takes care. You just focus on the science. This has played a crucial role in developing many aspects. For instance, ICTP was a hub where people from the different parts of the Iron Curtain would meet during the Cold War era. It's very well documented. Professor Spenta Wadia, who's the founding director of ICTS, had this picture of having a center like that in India. We never had that. So that's his brainchild. And he actually brought it to fruition, and that the result is ICTS. So programs are a major component. We have something like 30 to 40 programs throughout the year. On a given year, we have 30 to 40 programs. Many times there are parallel programs running, one small program, one big program. We have in-house facilities like a guest house. There's a dedicated team to take care of all the running of the program, childcare facilities, cafeteria, sports, everything. So it's a well, self-contained environment where you can come spend time and, focus on the program that you're attending and have a good life. So that aspect is one. The third aspect is outreach. Again, Professor Pentavadia had this picture that, it's great to do science, get international people and all, but then you should also go back to the masses. I mean, the job of a scientist is you find out things, but you should also communicate, particularly in India, where most science is funded by the taxpayers' money, right? I mean, we owe it. It's a kind of a responsibility to whatever you discover, you go back and give it back to the public. And it's
absolutely,
somebody puts their trust in you by paying you to do what you love. It's your job to take it back and explain things to the natural world. So outreach is another third aspect of the game. So there's research, there's programs, and there's outreach. And these three are sort of interconnected very, very tightly. So many of our outreach speakers are participants in our programs. And many of our faculty organize these programs. So one thing to emphasize is ICTS is not a conference center. It's not like somebody just comes and organizes a meeting. We also shape the program. I mean, there's a program committee which looks at the proposals, which gives scientific technical feedback on how to run the program, and also helps you with all the logistical details of running the program smoothly. So this tight interconnect between the three phases makes it a very unique place.
Unique place.
I don't know any other place in India that does this. So that's been a fantastic, early days, many of us faculty, we would attend almost all the programs. Now there are too many. You can't attend so many. How many will you attend? Everything looks fascinating.
So many good ones, yeah.
So many good things. And at one point of time, you just keep adding videos to your YouTube playlist. I'll watch this, and the list grows to hundreds and hundreds, and you don't have time. So at some point, it becomes a bit too much. But then there are fantastic programs across all science, all areas or branches of science. And this sort of also acts like a knowledge repository, because unless the speaker objects, we record the programs. And so the recording is put up on a YouTube channel. Yeah. And so this becomes a repository where, you want to learn some subject. There's a school at ICTS. You just go watch the videos. And there's literally a classroom going on there, and the speaker works out things on the board, and you learn that. There's an interactive session. Many of us, me at least, whenever I want to learn some subject, most of the time you Google on YouTube, the first thing you typically get is the ICTS program. Well, what do you want? So you go learn there, and so that becomes a huge difference.
In fact, that is something I would want to emphasize a lot of people to really look up, because, there are now dime a dozen YouTube channels and other things which probably provide information, some of them are very good. But this is actually a great resource. In fact, something needs to be actually more publicized, because that is a great resource of information, which has authentic information, more updated and cutting edge. And please carry on.
So it sort of ranges over several things, right? So we have things which are like schools, which are more pedagogical, at the master's or at the early PhD level schools. Those will be more pedagogical, more elementary. But then there are things which are sort of interface between school and research meetings. Yeah. They'll be more advanced. And then there are research discussion meetings, which will be really at the cutting edge of knowledge.
Absolutely.
And so the kind of people that we get is just fantastic. I mean, people come from all over the world. There's a significant international component.
Yes.
And that makes a huge difference, because people come, discuss ideas. And if you haven't come, you have come, of course. If you haven't come, please come to ICTS. The environment itself makes a huge difference to the one way one learns. Yeah, so that's the aspect of the programs. The outreach aspect, when we moved into a new campus, the place where I am right now, so we earlier had a small temporary campus in the ICTS of our building. That's when I joined, we were there for about 1.5 to 2 years. We made the transition to the new campus somewhere around 2016 is when we made the transition. And so there were a couple of outreach lectures organized in the earlier times too. But there was an effort, particularly our director, Professor Vijaykumar, sort of made a pitch that we should do something more long-term, sustained at a regular level. And it should also be something attractive, being a crowd puller, and then that makes a difference. So I expressed interest, and so there's a team of people. So CAPI is a product of a bunch of us put together. It's not just me alone. That would be wrong to say. There's an outreach team.
Yeah.
There were several faculty, also admin support staff, and they all played a crucial role in this. So the idea of a CAPI with curiosity came up because there is chai and why in
wonderful. Right? Arnab
organizes this from a long time. It was very
amazing.
Fantastic set of talks, right?
Yeah.
So so rather than getting people into a scientific institute, the science institute must go to the public. It's nice if you organize a public lecture in a scientific institute, but there is an initial barrier. Just getting past the security guard and that elitist environment, and many people will just be put off by that. So we wanted it to be, you don't feel hindered going to watch a cricket match. You don't feel hindered going to watch a musical program. Why are you hindered going to watch a scientific lecture? If music and cricket are as important a part of your culture, so should science be. That was the picture that we had in mind. And so one should really, be in a situation where I decide, today is a Sunday afternoon, there's a good scientific lecture, let me just go and listen to that.
Wonderful.
Rather than, it should be as casual as that. It shouldn't be like, oh my God, it's science and should I go? That shouldn't be there. I mean, it's not that you need to be a technical expert in science. We just want to understand, enjoy the world. People have discovered something about the world and they're happy to share that information. Just come, listen, get fascinated. Maybe that enthusiasm will rub off you, maybe it will rub off to your children, maybe it's to your friends. That was the whole idea, to create a scientific temperament in the city. And so we began this idea, and so it was chai and why, and being Bengaluru, it has to be copy. I mean, it shouldn't even be coffee, it should be coffee. I mean,
Nice.
copy so copy copy and so then we decided it should also be curiosity there. So that's how Copy with Curiosity was born. And so we wanted to, for two reasons. One is, of course, to ICTS is a little away from the city outskirts. Getting people here is one difficulty, but more importantly, idea, like I said, the science centers should go to the public. It should be in a scientific. It should be a scientific talk in a publicly accessible place. People shouldn't be scared to come there. It should be as natural as going to a park or something like that. So by natural connection with the planetarium really helped me there. And so I suggested this. The planetarium was very receptive. And so we've been running with them since 2016. 2016, December was the first talk. The first talk was by Professor Ashok Sen. I talked about the universe. And what is the best way to start the new program?
You can't get a better speaker also.
It was fun. So far it's been very good, very successful. Again, like all our ICTS programs, unless the speaker objects, we record, and most of them nobody. These are public lectures. These are lectures where people bring in lots of videos, animations, movies, and sort of to fascinate the public and to fascinate school children, college children. And one of the nice things about the Copy program is the following. There's a talk, there's some introduction, there's the talk itself that happens there. And after the talk, there's a question answer session.
Nice.
There's a huge question answer session. So one of the things that we emphasize is you should not be scared to ask questions.
Absolutely.
So that's very important. That's an absolutely fundamental tenet of science. Ask questions. So there are no stupid questions. It's okay if you don't know things. Ask and just develop the habit of asking. So people ask questions. So there is a post-talk Q&A session where people ask questions. But then there are still people, who have a bit of a hesitation to ask and things like that. So we realized this, and what we did was that we organized a copy session. So it's Copy with Curiosity. So after the talk, there is a coffee served there. And that's where the speakers get hogged completely. So there's a 20-30 group of kids who go and surround the speaker, and then they open up. It's more of a less formal setting, and somebody who's just having a coffee and you just want to so that opens up a lot. That makes a huge difference. People open up, people ask questions, and there are hubs. People sit down and discuss things there. That makes a huge difference. This should grow. Efforts like this should be sustained. They should be there in every part of India. They should be more and more in regional languages. That's something I'm really keen. I hope I get to do that someday. One should show that, science and the ideas of science are not something to be understood in English. Science is just about the natural world. You can understand that in your mother tongue as well. So, Kannada yak madakagalla, Hindi mein kyun nahi kar sakte? If you do that, that sort of connects to people at the ground level, right? That's how one should think about science as part of my living, and not something which happens in elite institutes, and that sort of really hinders. One should really push this more into the local languages. That's really, really important.
Absolutely. I totally agree with what you're saying. So we've got a beautiful gist of a lot of things, what you do, Vijay. In fact, it's been a fascinating conversation. It's wonderful. So tell us a little bit about your future plans, both in terms of research and outreach, and then we conclude.
Yeah. So right now, I'm not part of the outreach team. There are other colleagues who should also shoulder the responsibility. They're doing that aspect. It's going very well. In terms of research, as you know, we started this new. First of all, not the research aspect, a new PhD program called Physics of Life. So this is a first time in the country that we are starting this. This is a TFR interdisciplinary program. It's a TFR wide program. So right now it's anchored between ICTS and NCBS. So we are looking for students who have training in physics, math, engineering, computer science, not traditional biology training, but having been trained in these hard or quantitative sciences, they're curious to explore how living things work. So we want to catch hold of such people and give them reasonable amount of coursework and lab training in the necessary stat phys, active matter, information theory, dynamical systems, pattern formation, whatever is required there. And then they choose advisors either at ICTS or at NCBS for now. Eventually, the hope is that this will become a TFR program. And the hope is that, if you do this for a decade or two, there will be a cohort of people who have a training in physics, math, computer science, engineering, but are interrogating the physics of living systems, both in theory and experiment.
Nice.
The hope is that, you do this enough, there'll be a community which will develop, which will have a common language to converse with each other. And hopefully we will, bring in biological physics as a strong discipline within India. I want to emphasize, one of the questions that you asked about why should I come to physics of life? This is something I am really fascinated about. One of the questions that comes up is this physics? I want to do physics, but is this physics? So there's a nice, as somebody who works on this, of course it's physics for me. There's no doubt about that. But then for traditional areas, there's a question about how is this physics? So this was a very nice report that came about. So it turns out that every 10 years or so, the National Academies of Science, Engineering, and Medicine in the US, so they put together a committee, and the committee comprises experts in various areas. And the committee sits together for a couple of months, and they are tasked with assessing, look, where is this field going in the next 10 years?
Yes.
What are the new areas that will open up? And it's a nice task that is commissioned by the government because they want to think about, where to put funding, where to put emphasis on, where to develop educational programs, and so on. So 22, turns out there's this decadal assessment of physics. And in the 22 assessment, biological physics stands as a proper branch of physics, alongside condensed matter physics, astrophysics, all the other traditional branches of physics that we know of. So it's a proper branch of physics. Now, is it just, to say, this is physics, I'm doing physics? No, there is a technical statement about that. I wish our, academies take up this more seriously. What does it mean practically? We all learned physics from Resnick and Halliday. There would be basic physics. At the end, there would be a chapter on astrophysics, or cosmology, or particle physics, or condensed matter physics. That's sort of showing that these kinds of problems are physics, and these kinds of problems you can understand using the basic formalism that you learned in the previous chapters. Maybe electromagnetism, maybe quantum mechanics, maybe stat mech. So if there's a chapter I said Resnick and Halliday, but any undergraduate textbook, if there's a chapter on biological physics at the end of that textbook, that will really show people, I can understand the living world using the laws of physics.
Absolutely.
That makes a huge difference, be it at the 11th and 12th level or be it at the BSc level. That will make a huge, huge difference. I really wish that happens. Institutions like academies take care of that and address that problem. And yes, you are doing physics, you are doing mathematics, but possibly really complex physics and mathematics is what biology gives. In terms of research, I'm fascinated by cell and developmental biology. That's been a long-term fun for me. I'm looking at problems in cell division, problems in tissue morphogenesis. I collaborate with experimental colleagues, both within India and abroad. I am trying to work on a bunch of problems where one tries to see this intersection of mechanics, geometry, and information. Mechanics in the sense of active mechanics, active matter, fluid dynamics, elasticity, these kinds of things. Information in the sense of the gene regulation, the information content of GNA, and geometry in the sense of how shape and form and function come up. Again, the inspiration is D.R.C. Thompson's Growth and Form, right? So we all learn that you take a fish and do some canonical transformation and that becomes another. So there are laws underlying how and why things take on those particular shapes that they are. Why is it that we have a head and a trunk and a torso? Even at simpler systems, one tries to understand the development of shape formed, how it is regulated, how it is controlled, how is it that the information content of DNA is played out in space and
Hmm.
time to build these structures. That's something that really fascinates me a lot and doesn't give me sleep at night. I hope I'll be able to continue that for a significant period.
Wonderful, wonderful, Vijay. In fact, I'll be also linking a lot of the stuff what Vijay mentioned about, including the National Academy of Science USA's report. And thank you very much for this fascinating overview of all things related to physics of life and also a life in physics. That's you know that's something which is important. If one looks at this whole area of physics of life, and there's a lot of stuff which has been written about it in recent times. One of the significant ones is a series of articles and essays written by William Vehicle. Um, uh,
Bionic,
who-
will be Bionic.
yeah, and he does mention very beautifully in one of the APS News opinion piece where he mentions once an awkward confrontation between disciplines, biological physics is having its moment and showing that life is not just a mess in that sense. So it's a very important way of actually looking at this problem in a significant way. And there's a lot of hope in this emerging area of research. And Vijay and his team have been actually at the center of all these things.
In
So
fact, Bill Bionic is the chair of the committee who wrote that
yes,
NASA mission. So he's the
yes,
same.
yes, exactly. In fact, I'll be also linking that particular thing in the references. Do have a look at it, all of you who are watching and listening. So thank you, Vijay. Thank you very much. ಧನ್ಯವಾದಗಳು.
Thank you.
Really,
ತುಂಬಾ ಖುಷಿ ಆಯ್ತು. Had
yeah,
fun.
yeah, yeah. In fact, that's the amazing thing, to also see how people actually evolve over a significant period of time, and it's a parallel kind of a development, right? Because I have also seen Vijay, both of us have been coming from the same kind of environment and place, and it's so happy to see you do so well, and wish you all the best for your future ventures. And of course, the wonderful copy with curiosity. Let the curiosity really, flourish in all parts of India and the world. That's the most important aspect. Yeah.
Thank you, Pawan. It was fun being on the show. I've admired this from the beginning since you started this. So it's wonderful that I was able to be part of this. Thank you. Thanks for having
It's
me.
my pleasure. Absolutely my pleasure. So this is Pratidwani, where we try to humanize science. ಈ ಸತಿ ವಿಜಯ್ ಕುಮಾರ್ ಕೃಷ್ಣಮೂರ್ತಿ ಒಂದಿಗೆ. Thank you, Vijay.
Thank you.